David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Today's topic is using sums to find sequence parameters. So we're going to be given the sum of various sequences, and then we're going to have to manipulate using algebra to find the various parameters, values of certain terms, the number of terms, etc. So here's our first problem. Arithmetic series, Sn, the sum of this series is minus 126. We're also given the first term is -1, and we're given the nth term is -20. Now it's going to ask us, find n. So go ahead, take a look at your notes, figure out which sum formula you're going to use, and do your plug-in step. All right, so this formula is the one to use because basically we have the sum, we know u1, and we know un, we just don't know n. So I went ahead and picked that formula, and then I did my plug-in step here, just plugging my values in where they belong. Now go ahead, pause the video, crunch the numbers, and get the number for n. Okay. I showed you one intermediate step. What I did is I multiplied through by 2 to get this fraction taken care of. Minus 256 equals -21n after distributing the n on my 2 numbers in there. Divide through by -21, and I get n equals 12. Let's try another one. This one's a little bit tougher. The second term of an arithmetic sequence is 7. The sum of the first 4 terms is 12. Find the first term and d, the common difference. So this is a 2-stepper. We're going to need to find an expression for the first term. We can't find the first term until we find d, but we can find an expression for the first term. So go ahead and do that step. Find an expression for u1. All right, let's take a look at this. So here's my terminology, my expression to find the nth term, sum n. So the second term is 7, and I just plugged it in, u1. 7 is going to be u1 plus 2 minus 1, because the second term, that's my n minus 1, 2 minus 1, d, or u1 plus d. So you can pretty much go right to that if you understand what's going on. Remember, the common difference in an arithmetic sequence gets added to each term. So u1 is going to be 7, which is u2, minus that common difference. So you might have just leaped to that step, which is totally fine. That's an intuitive step that makes sense. All right, I've done a couple steps for you, and then I'm going to ask for you to go ahead and finish this. I brought our result from the last board over here. U1 is 7 minus d. We're going to need to do a substitution with that in a minute. Here's my formula. The sum of this sequence or series is going to be n over 2 times 2 times u1 plus n minus 1d. That's our standard formula that's using the variables that we have or almost have. So now I'm going to plug it in. I notice that I have a 4-term series. The sum of the first 4 terms is 12, so I can pop that over here. Now I know in this case that n is 4, so I can put 4 over 2, and then I also put my 4 in for my n there. So now I have my plug-in step. Now what I want you to do is crunch this all the way down. You could substitute in 7 minus d for u1, and you can solve this entire thing for d. All right, let's see how you did. So I went ahead and crunched my numbers. 4 over 2 is just 2. I distributed that on the inside here. So I have 4u1, and then this is going to be 3d, but then I multiplied it by the 2, so I got plus 6d. So this simplifies down to that. Now I'm going to do my substitution. I'm going to put in 7 minus d for u1 on this step, and that's all I did there was just substituted that, carried my 6d down. Then I distributive property onto that. I get 28 minus 4d plus 6d. Subtract the 28, move it over. That gives me a minus 16. And finally, equaling 2d. So that reduces down. I get d equals -8. Now, go ahead and finish this. What is u1? All right, finishing this up, I have u1. Remember, this is what we found in that first board on this problem. u1 is 7 minus d, which is -8. So 7 minus -8 is plus 8. So u1 is 15. Let's do one more, because here's a series. 3, 9, 27 plus ... We're not specifying the end of this series yet. Take a look. Find the minimum number of terms, that's n, for the series to exceed 1,000. So we want to find the first n for which the series total is more than 1,000. So I want you to pause the video and think about how you might do that. There's a couple different ways here. See what you can get. All right, so here's a plug-in step that could get you started. The sum of a series, of a geometric series, if you didn't already catch that this is geometric, you should have. Our R value here is 3. We're just multiplying each previous term by 3 to get the next one, so on and so forth. So I'm going to use my geometric series summation formula, which is that one there. Now I'm going to do a plug-in step for this particular series. I have U1 times R to the n minus 1 over R minus 1. So now I want you to pause the video and see if you can come up with an algebraic way to find that n. So I'm just going to use a guess and check approach on this problem. And so what I did here was let's see what 5 terms gives us. So the sum of the first 5 terms of the series is going to be used by this. I've plugged my 5 in there for n and my r's from there, and I get 363. So obviously we have not exceeded 1,000 yet. So I want you to go ahead, pause the video, and see what you can do to find our n. All right, I just tried the next one. So let's try 6 terms in our series. So S6 equals all of that, plug in with my 6 for my n. Go ahead, crunch the numbers. I got 1092. So yeah, we've exceeded 1,000, but we're not at 1,000. Here's below, here's above. So what's the answer to this question? N equals 6. It wants the first n for which the series is bigger than 1,000. So that would be 6 because we're bigger than 1,000. So some of these problems are tricky with the wording. You have to pay attention to how they set you up. We could have asked, what is the largest n for which the series is less than 1,000? In which case the answer would have been 5, not 6. Now, one other way to do this. You could use your graphing calculator, perhaps quicker, more precise. Pause the video, get out your calculator, and try to do that. All right, so I just put my function into the calculator. I'm looking at this expression, wanting to find the x value that makes that expression bigger than 1,000. So I didn't put an equal sign, I put a greater than sign. I pull it out on my calculator, and this is the graph I get. I get this vertical line dashed, because that's not an equals, so that would be a dash, and it shapes for me the right side of that, because these are all the x's, or in our case n, that make the expression bigger than 1,000. Now I can use a calculator to find out what the value of that line is, and I get x equals 5.92. So if you plug 5.92 in for x, you're going to get this expression equals 1,000 exactly. But we don't want that. We want the number of n, the whole number of n, that makes the expression bigger than 1,000. So the 5.92 is not the correct answer. If you use your calculator to do this, you have to do one more critical thinking step to go, well, we don't have a 5.92 term. We have a 5th term and we have a 6th term. So you have to look at this graph and go, oh, well, that means I need to go all the way to the 6th term to have this expression be greater than 1,000. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.